This is the fourth and last question that we will be solving on energy levels, and I'm sure that after solving the last three questions, this one will be very easy for you to solve. So the first question is, add arrows to the diagram showing all the single transitions which could ionize the atom. So remember, you have to draw only single transitions which could ionize the atom. So the first transition will be from the ground state directly to the zero energy level. The second transition will be from negative 3.39, and the third one can be from negative 1.51 to 0. The second question is, why is the level labeled negative 13.6 electron volt called the ground state? Remember, I explained why we call the lowest energy level ground state. We call it ground state because it is the level that has the lowest energy and the electrons are most stable in the ground state. The last question is, identify the transition which could result in the emission of light of wavelength 660 nanometers. Now, this is the exact same question that we solved in question 3, but I'll repeat here. First thing you want to do is you want to find the energy of photon that has a wavelength of 660 nanometers. So for energy of the photon in terms of its wavelength, we have the equation hc over lambda. H is the Planck's constant, c is the speed of light, lambda is the wavelength. We substitute all of these numbers, and you should always remember that you will get this answer in joules. But we have to compare the energy in joules with the energy of these levels, which is in electron volts. So we need a conversion factor to go from joules to electron volts. Can you figure out the conversion factor? It will be 1 electron volt divided by 1.6 times 10 to the negative 19 joules. And we use this factor because the joules will cancel, and we'll get our final answer in electron volts. And if you solve this, the answer will be 1.88 electron volts. Now you just have to find the two levels for which the energy difference is 1.88 electron volts. If you find the energy difference between negative 1.51 electron volt and negative 3.39, you will see that the difference between these two levels is exactly 1.88. I'll also solve it here. So the difference in energy levels will be energy of the final level minus energy of the initial level. Since the electron is de-exciting, so the final level will be negative 3.39, and then we have to subtract from it the initial level, energy of the initial level, which is negative 1.51 electron volts. And you will see that the answer is 1.88 electron volts.